So have you ever stopped and wondered if we're using up our planet's resources way faster than they can bounce back? It's a huge question, right? And today, we're going to dive deep into the fundamentals of environmental studies to get some real answers. We'll figure out what our environment actually is, trace our pretty dramatic impact on it, and then we'll look at the blueprint for a much more sustainable future. And this really is the question that's at the heart of it all. Are we living on borrowed time? And this isn't just some philosophical thought experiment. It's a really practical question about whether the very systems that give us our air, our water, and our food can actually keep supporting us if we stay on our current path. To even start to answer that, we first need to get super clear on what it is we're trying to protect. So before we can even talk about saving the environment, we have to agree on what it is. I mean, it's a word we throw around all the time, but its real meaning goes so much deeper than just pretty landscapes and wildlife. It's a complex, living system that we are all a part of. On the surface, yeah, the environment is just everything that surrounds us. But the scientific definition, that's a bit more precise. It's not just the individual living things, like plants and animals, or the non-living things, like water and air. The key word here is interactions. It's the sum of all of those connections, creating this dynamic web that directly affects our lives and our well-being every single day. And this, right here, is why environmental studies are just so complex and interdisciplinary. You just can't look at one little piece of the puzzle. The source material gives a great example of this. Let's say you want to protect an endangered species, right? So you declare a big area a protected wildlife reserve. Seems like an obvious win. But what if that pushes out the local people who've lived there for generations? Well, now you've got new social and economic problems, and people might get so desperate they turn to illegal poaching, the very thing you were trying to stop. It just goes to show a good solution has to look at the whole picture. So the crucial point is that you absolutely need to understand the science, the economics, the sociology, the policy, all of it, all at once. And to build that kind of understanding, we've got to start with the real fundamentals, the basic components of our planet's life support system. Okay, so our planet's whole life support system is built on these four interconnected spheres. You've got the atmosphere, which is all the air, the hydrosphere, all the water, and the lithosphere. That's the solid ground beneath our feet. But the magic happens where they all meet, in the biosphere. This thin, fragile layer is where all known life exists, and it's all fueled by the constant exchange of energy and stuff between the other three. Now let's just zoom in on one of these spheres for a second, the atmosphere. It's easy to think of it as just, well, air, but it's actually this incredibly complex stack of different layers, and each one has a vital job to do. So let's take a quick trip up, from the ground all the way to the edge of space. We live right down here, in the troposphere. It's the bottom layer where all our weather happens. But just above that, you've got the stratosphere, which is home to the all-important ozone layer that protects us from the sun's nasty UV radiation. And as you go higher, through layers like the mesosphere and thermosphere, the jobs change, from burning up meteors to bouncing radio waves around the globe. The main takeaway is that our atmosphere is this sophisticated, multi-layered shield, not just empty space. And the other spheres are, of course, just as critical. The hydrosphere, all our oceans and water, it covers most of the planet and acts like a massive climate regulator. The lithosphere, the Earth's solid crust, gives us essential minerals. And finally, there's the biosphere, that incredibly thin, precious zone where land, water, and air all overlap to create the perfect conditions for every living thing we know. For almost all of our history, humanity was just one species among millions. Our impact was, well, relatively small. But then, in what is basically the blink of an eye in geological time, something changed that put us on a collision course with the very systems that keep us alive. Just look at this graph. This right here, this is the human story for pretty much its entire existence. For hundreds of thousands of years, through ice ages and the rise and fall of empires, our population barely moved. It was a long, slow crawl, with our numbers kept in check by the natural limits of the world around us. And then this happened, starting around the 1800s with the Industrial Revolution, and then accelerating like crazy in the 20th century. The curve just goes vertical. This is exponential growth. It's often called the Great Acceleration. And what drove it? Incredible advances. Things like antibiotics and vaccines, the Green Revolution in agriculture that massively boosted food production, and huge improvements in our socioeconomic condition. And here is the fundamental problem of our modern world.
Our population, and just as importantly, our consumption, are on this exponential J-shaped curve, growing faster and faster. But the Earth's ability to provide resources, things like clean water, forests, fertile soil, that grows at best at a slow, straight, linear rate. You don't have to be a math whiz to see the issue here. An exponential demand hitting up against a linear supply, well, that's a recipe for a collision.
This collision course is, by its very definition, unsustainable. We just cannot keep going on a path where what we demand so vastly outstrips what the planet can supply. So, how do we fix this? How do we actually redesign our whole model of progress? Well, the guiding concept, the North Star for this redesign, is sustainability. This right here is the classic, most widely used definition of sustainable development. It comes from a 1987 report called Our Common Future. Let's just break that down for a second. It's about meeting our needs today. Notice it says needs, not wants, and doing it without compromising the ability of our kids and grandkids to meet their own needs. At its core, it's really a principle of fairness between generations. To actually achieve sustainability, you need to balance three essential pillars. Think of it like a three-legged stool. You need environmental protection, obviously, but you also need social equity, making sure there's fairness and opportunity for everybody. And you need economic viability, so people can actually make a living. True sustainability is found only in that sweet spot where all three overlap. I mean, think about it. A super profitable factory that pollutes the river, that fails the environment. A beautiful park that kicks out a poor community, that fails social equity. All three have to work together. And listen, this isn't just some abstract, fluffy idea. The world has a concrete plan. Back in 2015, the United Nations laid out the 17 Sustainable Development Goals, or SDGs. They're part of a global agenda called Agenda 2030. And they cover the whole shebang, from ending poverty and hunger, to ensuring quality education and gender equality, to providing clean energy and taking urgent action on climate change. This is basically humanity's shared to-do list for a better world. Okay, so we've got the concept, we've got the plan, but where are we right now? How are we actually doing? To measure our progress, or maybe our lack of it, we can use a really powerful tool called the ecological footprint. The ecological footprint is kind of like a planetary accounting system. It measures our demand on nature against what nature can supply. And this graph shows the exact moment our spending went past our income. That line at 1.0 is the Earth's annual budget. And right around 1970, we crossed it. We went into what's called ecological overshoot. What that means is we're no longer living off the planet's annual interest, we are draining the principal savings account. And that's a debt our planet is going to struggle to repay. But here's the thing. That overshoot, that debt, isn't being created equally, not even close. This slide shows how many Earths we would need if every single person on the planet consumed resources at the same rate as the average resident of these different countries. You can see the massive difference. The world average is about 1.75 Earths, but a lot of developing nations are still living within the means of one planet. In contrast, developed countries are using a massively disproportionate share of the world's resources, often many times more. And this single number, this really brings that inequality into sharp focus. 5.1. That is how many planets we would need if every single person on Earth consumed resources like the average resident of the United States. And we only have one. And so this brings us right back to where we started, but now with a much clearer picture. The data is undeniable. Our planet has limits, our collective demand is blowing past those limits, and the weight of that consumption is spread out incredibly unfairly. This leaves us with the ultimate design challenge for our century. How do we build a world that is fair and prosperous for everyone, but one that also respects our planet's boundaries? How do we create a future that provides for all of us while living within the means of our one and only Earth?